Hello, Hopewell. This is Mr. Steinberg. Today's lesson is 9.2. Today we're going to draw a lot of angles in our coordinate plane. The lesson title is called Define General Angles and Use Radian Measure. We can measure angles in degrees, but another way we can measure them is in radians. We'll get to that a little bit later. Since I want to draw angles in the first section, I want everybody's answers to be the same. In order to do that, we have to work out a way to represent all of our angles that we draw, and we'll call that a standard position. So we're drawing angles in our coordinate plane. So we have our x-axis going left and right, our y-axis going up and down, and in between where they meet is the origin. The angle is drawn in standard position if the vertex of that angle is the origin and the initial side. Where the angle begins, its initial side, is the positive x-axis. So from the right of this origin. Every standard position angle begins in the same spot, starting with the origin and drawing a ray to the right. This is the initial side where the angle begins. Now we can rotate an angle in either direction. This orientation going this way is called counterclockwise, or underneath the x-axis to begin would be clockwise. These two things mean different and represent different angles. If we draw an angle this way or that way, they are different. We will talk about that later. Wherever the angle is ending up, that's what we call and consider its terminal side. So this angle begins in its initial position, the positive x-axis. It got rotated counterclockwise, and it ended up somewhere in this quadrant. This is our second quadrant. What I think I want to do is I want to just review for a quick second how we label our quadrants. This is quadrant 1 in the top right, quadrant 2 is the top left, quadrant 3 bottom left, and quadrant 4 bottom right. Now if you notice, we numbered these quadrants with our Roman numerals in this counterclockwise method. Top right, top left, bottom right. Okay, so what we have here is an initial side on the positive x-axis. The terminal side ended up in quadrant 2. It doesn't always. But I wanted you to notice that we number these quadrants the same way in counterclockwise fashion. So the one definition I have not spoken about is called a reference angle. What is a reference angle? It's an acute angle formed between the x-axis and the terminal side of the angle. So by this definition, here's the terminal side of this angle, this ray right here. And here's the x-axis. I mean, it's also over here, but this angle is an acute. The acute angle formed by the x-axis and the terminal side is located on this side in quadrant 2. The reference angle, I'm just going to write REF, would be the angle formed by the x-axis and the terminal side. It is always the x-axis. It is never the y-axis that forms the reference angle. Alright, to finish up this top part, positive angles and negative angles. Positive angles are rotated in which manner? Positive angles are rotated in this manner, which we call counterclockwise. Which means negative angles are formed when we rotate in a clockwise direction. Okay, this concludes our first section. We talked about our quadrants, our standard position. The initial side is always the positive x-axis. The terminal side ends up somewhere else. And when we rotate it in clockwise fashion, that would be a negative. Counterclockwise would be positive. If you're not sure of that, then remember how we label our quadrants. Quadrant 1, 2, 3, and 4. That's regular, so that's a positive angle. At the very bottom, we'll do 6 of these exercises. Maybe we'll do most of them. I'm not sure I'll do all of them, but we'll take a look. The directions say draw each angle with a given measure in standard position. Label the reference angle. What it means to label, it doesn't just mean to like mark it with a theta like I did up here. I think what it means is what we're going to do is we're going to find the value of this reference angle. Okay, so let me slide this back up. I'm going to leave those words up there because I want to remember that. Starting with 240 degrees, the initial side starts with a vertex at the origin and a ray that covers up the x-axis. This is the initial side of the angle. This would represent 0 degrees if I have an angle that begins and ends here. But this is just the initial side. If this were the terminal side, that angle would be 0 degrees. Now we're going to rotate this angle positive 240 degrees. Positive angles are rotated counterclockwise, so I'm going to go in this direction. 90 degrees is exactly north of the origin. This would be 90 degrees. To the left of the origin, or west of the origin, would be 180. 270 would be south. Okay, so now 240, I know it lies somewhere between 180 and 270. Closer to which one? 240 would be closer to 270. So I'm going to just guess at where that would be and call this 240 degrees. Now, very important I do the following. I need to mark the direction in which this angle was rotated. And we said it's counterclockwise. Or else somebody might think that it's a negative angle. So I have to draw this little spiral here. So here's my initial side, my terminal side, and this is the direction of my rotation at 240 degrees. The next part of the direction says find the reference angle. The reference angle is formed with the x-axis and the terminal side. So if I see the x-axis and the terminal side, this is our reference angle. What's the value of this reference angle? They didn't just say label it to mark it, but we need to find the value of it. How much larger is 240 compared to 180? That angle formed, that reference angle would be 60 degrees. So the reference angle would be 60 degrees for this exercise. Take a look at question number 2. We can't have an angle that's bigger than 360 degrees, more than one full revolution. So 810, that's going to take a lot of time to do, but we're going to do it anyway. We got nothing but time to do this exercise. So this would be 0 degrees. Here's my initial. Here's the initial side, 0 degrees. And if you can count by nines, this will make things a lot easier. 0, 9, 18, 27, 36. Why counting by nines? Because we're counting all these by like 90s. Each quadrant represents 90 degrees. So where do we leave off? 360 degrees, 450 degrees, 540 degrees, 630 degrees, 720, 810. Alright, so 810, the terminal side of this angle would be this vertical axis, or this y-axis. One more time, I can't just draw the initial side and the terminal side because we may not understand that it's more than 90 degrees. We might think that this is 90 degrees. We have to do this little spiral thing. So we went one full revolution, 2 full revolutions got us to 720, and then one more quadrant more got us to 810. This is the standard position for 810 degrees. Now, according to our definition, our reference angle is an acute angle. I would think that the angle formed by the terminal side and the x-axis would be 90 degrees. However, is 90 degrees acute? The answer is no. If it's directly on the axis, well, you can't really have two reference angles because this side is also 90 degrees. They're both the same. So I would say in this instance, it doesn't happen often, but in this instance, I would say that no reference angle exists. So I'm going to write no ref angle. I'll use the angle symbol there. That might be the only one in this whole section that doesn't have a reference angle. Let's see if there are any others. Now, number 3 is the first time we encounter a negative angle, which means we're going to rotate the initial side starting from here, and we're going to rotate it clockwise. 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees. Alright, now negative 210 is between negative 270 and negative 180. Which is it closer to? It's closer to negative 180. So we'll put the terminal side here because we are marking a negative angle. I don't want to go counterclockwise. I want to draw the spiral going clockwise. Okay. Let's find our reference angle. How much farther than 180 was 210? We found that it is 30 degrees away. Now, a reference angle is never negative. It's an acute angle formed by the x-axis and the terminal side. So this is our theta, this is our reference angle. It is a positive 30 degrees because it's the difference. It represents the difference between these two angles. Okay? Taking a look at 4, 5, and 6. Kind of wrap this up. We're going to just repeat the same thing. I think I'll end with question 4. Maybe we'll do some more. Who knows? Here's the vertex, my initial side, 0, 9, 18, 27, 36. Okay, so I cheated. Again, counting by nines helps me count by 90s. 315 is exactly in between 270 and 360. So this is the initial side. Here's my terminal side of this angle. I'm going to rotate it positive direction, so that is counterclockwise, ends up here. The reference angle is formed by the x-axis and the terminal side of the angle. Here's our reference angle, which is 45 degrees. Now let's try negative 225, the initial side, always this direction. Negative 225, we're going to do clockwise. 9, 18, 27. Of course, these are negatives, so let's put negative 90, negative 180, negative 270. How far apart? Let's see, which one is this closer to? Is it closer to 270? Is it closer to 180? It's actually halfway in between again. This would be our angle, starting from our initial side, ending up here. What is our reference angle if it's exactly in between? It has the same reference angle as number 4. So number 5 and number 4 have the same reference angle. Do they represent the same angle? Absolutely not. They do have the same reference angle, but they don't represent the same angle. Take a look at number 6. Number 6 starts with this initial side, 510, 0, 9, 18, 27, 36. Okay, so it's more than one full revolution. 45, 54. Okay, so 540 degrees and 450 degrees. 510 is 30 degrees before, so it's going to be closer to the x-axis than the y-axis. I'm going to draw my spiral in more than once, and it's going to stop here. Here's my initial side, my terminal side. My reference angle, let's see, 510 and 540 are 30 apart. So this has the same reference angle as number 3. Actually, when I take a look at the questions, number 3 and number 6, they have the same reference angle. Their terminal side is in the same quadrant. We have a special term for this, which we'll start with on the next page. Number 3 and number 6 are called coterminal angles. We're going to describe what that means in our next video. Please proceed.